Good evening, children. Today we are going to have a session on D block elements using the pedagogy art integration. So it is actually a talk show we are planning, and all the students in the class have contributed, and this is the first time we are doing it, right from the beginning till end. I wish you all do it to the maximum. So let us start the session. I'm giving this to the organizing committee members. Okay, all the very best to everyone. Thank you. Yes, you can start now.
In the historic US elections, Democrat Joe Biden has defeated Donald Trump. Surely, this is the first time in history. Joe Biden promises to be the president for all Americans and uphold what America truly stood for. You know what history reminds me of, viewers? It reminds me of the fact that from prehistory to the common era, only seven metals gold, silver, copper, iron, lead, mercury, and tin were known to man. Of these, the first five are D block elements found in the central part of the periodic table. Just like the D block elements are found in the center of the periodic table, these play a central role in our everyday life as well. So gear up and join us as we embark on a journey to debunk the D and F block elements in our special coverage right after this break. Stay with us.
Good evening. Welcome to yet another episode of Chemtrail. Today we are here to introduce you to a revolutionary product that can shake up the market. I am your host Abel and this is my assistant Paul. So Paul, what products do we have for our viewers today?
So, hi Abel, good evening. Today we've got Chemtrail's range of thermometers, the newest addition to its line. So, today we'll be introducing to our viewers Chemtrail thermometers.
Oh wow Paul, that is really interesting and exciting. So without wasting much more time, why don't we bring out the product?
Sure, Abel, let's bring out the product. So, here we have the latest model of Chemtrail thermometers. Take a look and see how stylish it is. Our thermometers are designed to underlie precision and simplicity. The star of the show, mercury, is kept in a vacuum sealed glass tube. The mercury is expanded and contracted when air is heated or cooled. We use mercury because it is the only metal liquid at room temperature. It has high coefficient of expansion. The mercury then expands and contracts on the basis of change of temperature. You can buy this thermometer at a discounted rate of 9,999 rupees. Limited stock and limited number of units per customer.
Oh, viewers, we have a call from our MD. Let me attend it. Yes, sir. Okay, sir. Okay, sir. I will tell. Okay. So, dear viewers, I'm sure you are eager to know what the MD was saying. So the MD was saying that our stocks are disappearing very faster, and those who want to buy this thermometer should hurry this number given below within 1 hour, as this offer is valid only for 1 hour. So guys, please hurry up. You don't have much time left.
Welcome back, and thank you for staying with us on this fun and knowledgeable journey to understand the transition elements.
Your anchors for today will be Yashit, Yashwin, and myself, Priya. We'll be joined by our two in-house experts, Jaren and Rahul. Keep your mobile phones with you as we will be taking questions from the audience. Over to you, Yashit.
Hello there. Have you ever wondered what the atomic and ionic radii of transition elements are and how they vary? Watch this.
Hello? Hello?
It was a dark, cold night near the road. There was the house of the lady Amara, and she was busy doing her research papers. Her daughter, Mitra, was sitting in the room and was watching YouTube videos. Suddenly, she came across a video in YouTube which was about mercury. She was so excited and curious while watching that video. She called her mother and showed this video to her and even asked her to explain more about it. Her mother went to the shelf and took a book and started explaining it to her. She taught her that mercury is a crystal structure found in liquid. Its symbol is Ag and atomic weight of about 59. Suddenly, Mitra pointed the name transition element and showed more interest to know more about it. Amara, after taking a deep breath, started teaching her about transition elements. They are also known as, she told her that groups 3 to 12 in the periodic table are called d block elements. They are also known as transition elements. They show partial d orbital in the ground state as well as in any of the oxidation state. Many properties vary across groups and periods of d block. And one of the types of properties is atomic size. Atomic size is given by atomic radius. It can be defined as the distance between the nucleus and the outermost shell. In case of atomic size across a period, atomic size depends on the attraction between the nucleus and the outermost electron and the repulsion between electrons. This will be decided by the protons and electrons in the atom. In 3D series, as we move from scandium to titanium, an extra electron is added in the same 3D subshell and a proton is added to the nucleus. Further, as we move from towards zinc, more number of free electrons are added in the same 3D subshell and more protons are added. So with the addition of protons in the nucleus, the attraction between the nucleus and the outermost shell increases. This increased nuclear charge pulls the outermost electron towards itself. However, the inner electron added in the d subshell repel the electron in the outermost shell, but the d orbitals are diffused. And so d electron cannot repel each other to a large extent. Thus, we can say the shielding effect of d orbitals is very poor. So the attraction between the nucleus and the outermost electron dominates repulsion by the d electron. This pulls outermost electron inwards, and the size decreases from scandium to nickel. After nickel, new electrons added to the s orbital. Being spherical, the s orbital can shield the outermost electron effectively from the nucleus as compared to that of d orbital. Hence, the radii increases slightly from nickel to zinc. So overall atomic size trend in the 3D group looks like this. In the case of down the group, as we move from 3D series to 4D series, one extra shell is added in the atom. The increase in shell causes increase in atomic size. Therefore, the atomic radii increase as we move from 3D series to 4D series. How the atomic radii trend is not followed as we move from 4D series to 5D series down the group. As we move from 4D series to 5D series, the increase in atomic radii is very minimal. When we move from 4D series to 5D series, 14 electrons are filled in the 4 of orbitals. When the electrons are filled in the orbital, they repel the outermost electron. Due to this, outermost electrons are shielded from pull of nucleus. This effect is called shielding effect. F orbitals are very poor in shielding as they are more diffused in s-p-d orbitals. This effect is called lanthanoid contraction. So the increase in size from 4D to 5D due to the addition of shell is compensated by shielding effect. This atomic radii of 4D and 5D series is almost the same. Suddenly they heard a bell. Amara went to open the door. It was John, Amara's husband. He came home after business tour.
Excuse me, Malavika. I'm calling from the panel and we have actually received a question for you. So it is known that the density of nickel is 8.9 gram per centimeter cube and that of vanadium is 6.11 gram per centimeter cube. So what exactly is the reason for such a gap in this particular characteristic even though both of them are said to be transition metals?
The decrease in metallic radius is coupled with increase in atomic mass, results in the increase in the density of elements. For nickel, it is about 58.69. For vanadium, it is about 50.9. So nickel has more density than that of vanadium.
Yes, Malvika, thank you.
We have to interrupt normal coverage. Breaking news coming up which suggests that transition metals are showing high melting and boiling point. For more on this, we have our correspondent Femi Reggie on scene. Femi, can you hear me?
Yes, yes, I can hear you.
Over to you, Femi. Tell us what this is all about.
Yes,
Just a minute,
1
Femi.
minute.
I think we are having some technical issues. The screen of the previous presentation is still showing. I'll ask my technical department to rectify it. Yeah, Femi, you can continue.
Yeah. So good morning. This is Femi reporting live from Ramanjan Chemical Factory. Well, we can see that a lot of things are going on around here. All transition metals show metallic characteristics such as its malleability, ductility, high conductivity, high boiling and melting point, except a few like cadmium, mercury, zinc, and manganese. And this might be due to the overlapping of N-1 d orbital and covalent bonding of the unpaired d orbital element. So I am near the iron extracting area on the weaving of the factory. We know that iron is a strong metal and it is quite hard to extract. It requires high temperature to be brought in its pure form as it has high melting and boiling. Well, we know that transition elements are highly volatile and we can see that here in this case too it is said that the densities are seemingly high.
Sorry, Femi, I have to interrupt you there since we have a question coming in from Jamshedpur. Yes, sir. We can hear you, sir. You can ask your question.
Yeah, well, my question was, why do transition elements have high densities?
Yeah, so transition elements have high densities, which are due to metallic bonding by delocalized d electrons, leading to cohesion, which increases with the number of shared electrons. Coming back, they are less reactive than alkali metals. Many of these transition metals are used as catalyst on most area cases, and I can say that these transition metals form colored ions. That's all for now. This is Femi Raji from Good News, Good Day News signing out.
Technical team, please make sure that the camera is working.
Yeah. Now, for our younger viewers, to make sure that the stress, boredom, and frustration of the pandemic does not come in the way of your learning endeavors, developers at our parent company have come up with a solution just for you. Check it out.
Hi students, we are here to give you a demo on our new and innovative learning app, Let's Learn.
So this app consists of many features. Let's Learn offers highly adaptive, effective, and engaging personalized learning. Today we'll be giving you a brief idea about atomization and ionization of D and F block elements.
So let's start with atomization. So due to this large number of unpaired electrons, they have strong interatomic interaction and hence strong metal-metal bonds. So they have high enthalpy of atomization. So what is enthalpy of atomization? It is the energy required to break the metal lattice to get free M atoms.
Now, ionization enthalpy. As you all know, ionization enthalpy is defined as the energy required to remove the most loosely bound electron from the isolated gaseous atoms to produce a cation. The ionization enthalpy of transition elements generally tend to increase from left to right in the periodic table. There is an increase in the nuclear charge which accompanies the filling of the inner d orbital. So transition elements have small size which results in high ionization enthalpy. The d block elements exhibit an increase in the ionization potential from left to right due to the screening effect of the new electron added into the n-1d subshell. The first transition series exhibit an increase in the second ionization energies with the increase in atomic number due to the stable electronic configuration. Generally, ionization energy decreases down the group and ionization energy increases across the period. Hope you all understood the concepts.
So as you can see, our app not only deals with the main and important direct points, it comes along with many important features.
Hope you all will download our app and discover more.
Let's move to the first interview of this program. We have Aditya and Jaren with a very special guest, Joshua.
Good morning to one and all. I'm Aditya, reading from the Daily Beagle. So there has been a rising issue in what is the cause of combustion, respiration, and corrosion that are seen in our daily life. To know more about this cause, we would like to invite a special guest who is a professor of Oxford University and also his subject is chemistry. So I would like to invite our special guest, Professor Joshua. Joshua.
Good morning. Good morning, Aditya.
So, Joshua, your first question is, sir, what is your opinion about the process such as combustion, corrosion, and respiration, which is a naturally occurring process?
Actually, my opinion is that corrosion, combustion, and respiration are actually caused due to oxidation.
Okay, Joshua. So the next question is, sir, what do you mean by oxidation?
Actually, oxidation means the loss of electrons. Oxidation occurs when oxidation state of molecules, atoms, or ions is increased.
Okay, sir. So what is the significance of oxidation state?
Actually, its significance is that it refers to the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom.
Okay, sir. So there has been many questions on why D block elements do not show variable oxidation state.
Actually, D block elements, also known as transition elements, is as a configuration as n-1 or D5NS2 or n-1 D10 NS1. These elements show variable oxidation state because the valence electrons are in two different sets of its orbit.
Okay, sir. So, sir, what is your opinion on why higher oxidation state of transition metals are unstable?
It is because as the number of unpaired valence electrons increases, the d orbital increases. The higher oxidation state also increases. This is because the unpaired valence electrons are unstable.
Okay, sir.
I have a question for you.
Okay.
Well, could you tell us what's the most common oxidation state of D block elements? In a quite elaborate way.
Except scandium, the most common oxidation state is actually shown by the elements of first transition series is +2. This demonstrates that the d block or the d orbitals are more stable than the s orbitals.
Thank you, sir.
Okay, coming back, so many people are curious about the trend in oxidation state of transition metal. Could you please comment on that?
Here the highest possible oxidation state correspond to the formal loss of valence electrons becomes increasingly less stable. So as we move from 3 to group 8.
Okay, sir. So next question is, there were many queries whether transition metals were good conductor.
The transition metals are very good conductors as it allows passage of electric current and also they are malleable.
Okay, sir. Sir, the next question, are there transition metal which have only one oxidation state?
Certainly, yes. There are two transition metals which show one oxidation state. One is scandium, which is +1 oxidation state, and other is zinc, which also shows +1 oxidation state.
So, sir, for the final question, are there any transition element which has most number of oxidation state?
Yes, manganese has the highest number of oxidation state, and indeed the highest oxidation state in the whole period since it has 5 unpaired electrons.
Okay, sir. Thank you, sir, for joining us and giving. Thank you for joining and giving our viewers an informative session, sir. Thank you.
You're mostly welcome.
Thank you, sir.
Next, we have a special segment for you, for which I would like to welcome our senior finance correspondent, Alka. Go on, Alka.
In this pandemic-marred world of business downsizing, here we have two business experts, Mr. Joel and Mr. Thomas, and our very own Jaren.
Okay, so hello there. As we all know, in the current COVID-19 pandemic has forced companies to cut down on the number of employees. One such company, Stark Enterprises. So here we have three main departments, accounts, sales, and HR. The managing director of this company has decided that 4 employees must be kept in each of these main departments. The twist lies in the fact these 4 employees are highly efficient when they work independently. But when they work in a pair, the ideas of one person will contrast with the ideas of the other. So in a pair, we can say that the net productivity between these 2 employees is 0. Here comes accounts department. We have 4 employees. So like here the number of unpaired staff is 4. Number of paired staff is 0. So let's take the formula root of n into n plus 2, where n is the number of unpaired working staff. So here this is the form for productivity, and hence the value of productivity in accounts department is this is nearly 4.8 or 5. The second department, sales department, we have 2 unpaired staff and 2 paired staff. So as I said before, the net productivity inside a pair is 0. These two employees will only get time to contrast and conflict with each other. So here the value of productivity is root of 2 into 4. This is root 6, 2.8. Now here comes the next department, HR department. All of these staff are paired. So as you might have guessed, the net productivity inside the entire department is 0. Here's unpaired staff, paired staff, productivity, as you have guessed, 0. So this is finance. Let's come to chemistry. Let us consider each department as an atom. So here is accounts department with atom 1, and each employee is taken as an electron. So here each employee is unpaired, it is independent of the other. In sales department, Two are paired, two are unpaired. In HR department, all are massive gas paired. Yes, so each of these employees is taken as an electron, and productivity in our language is magnetic moment. So as you might have seen, when the number of unpaired electrons is higher, the value of magnetic moment is as a result higher. So let's see why this happens. So here is a pair of electrons. By the right hand thumb rule, which you learned in physics in grade 10 and 12, we see that a magnetic field due to one of these electrons is upwards and the other one is downwards. So in a pair, the net magnetic field is zero. So as you might have guessed, the magnetic field exists only when an electron is independent. Over to you, Thomas.
Yes, going to be explaining about paramagnetism and diamagnetism. Paramagnetism is a property which arises when there are unpaired electrons, and diamagnetism is a property which arises when there are no unpaired electrons, or which means it is a property which arises when there are paired number of electrons.
Okay.
Hello, sir.
Yes.
Could I just ask you a question?
Yes, sure.
So, are all transition elements and its compounds paramagnetic?
No, not exactly. All of them are not. For example, take the example of zinc. Zinc is an element which is placed along with the transition metals in d block. But as you know, zinc has completely filled d orbitals. Hence, there is like no unpaired electron, which leads to magnetic moment. So the magnetic moment inside zinc is zero, and hence it shows no magnetic properties. Okay, so now continuing with the presentation. So as you have seen, accounts department is the highest value of unpaired electrons. Hence it is paramagnetic. HR department is the least value of number of unpaired electrons, hence it is diamagnetic. The magnetism just dies off. So, over to you, Thomas.
Yes. Now I'm going to be explaining about paramagnetism and diamagnetism based on this slide. So here, based on this example, here chromium in the non-ionic form has the highest number of unpaired number of electrons. That is 6 unpaired electrons. And therefore it has the highest value of magnetic moment mu, and hence it shows greater magnetic properties. As Joel said, we calculate magnetic moment mu as root of n into n plus 2, where n is the number of unpaired electrons. Here, in chromium and cobalt, its magnetic moment has a certain amount as it has less number of unpaired electrons. But here, in the case of diamagnetism, zinc, Zn 2 plus and Cu plus has no magnetic moment as the value of mu is zero because there is no unpaired number of electrons.
Okay, so since we're running out of time, so let's conclude. Over to the organizing committee.
Thank you. By the way, Leah, those are some really colorful clothes you are dressed in today.
Yes, I wanted to learn one of our tapes for today. Didn't you know that D and F block elements form colored ions? Here is a special report by Teresa.
Welcome to our show, The Deep Science. We have Professor Josna joining us. To know more about the formation of colored ions, welcome Josna. Josna, can you hear me?
Yes, Teresa, I can hear you.
It has been found that the elements in DNF block form colored ions. Josna, can you give us a brief idea about the topic?
Yes. So when an electron from a lower energy d orbital is excited to a higher energy d orbital, the energy of excitation corresponds to the frequency of the light absorbed, and this frequency generally lies on the visible region.
So what do you mean by this visible region?
The visible region is the portion of the electromagnetic spectrum that is visible to the human eye. Electromagnetic radiation in this range of wavelength is called the visible light or simply light.
Oh, that's great. What is the reason behind it?
The color of the transition metal ions is due to the presence of unpaired or DD transaction.
Can you give us a detailed explanation about the topic?
Yes. So, the absorption of visible light and hence the colored nature of the transition metal cations is due to the promotion of one or more unpaired electron from a lower energy to a higher energy with the same subshell.
Oh, wonderful. What is the requirement for the promotion of unpaired electron?
This promotion requires small amount of energy that is visible to us.
So does all the elements in DNF block form colored ions, or is there any exception?
Yes, Teresa, there are exceptions like the scandium 3+, the titanium 4+, the Cu+, and the cerium 2+ appear colorless.
Oh, it's remarkable. What is the reason behind it?
These metals are colorless because they're either completely or empty filled d orbitals. Since they do not have any unpaired d electron, they appear colorless.
Since it's a very important topic for students, can you give us some tips to memorize it?
Yes. Generally, the Cu++ will appear blue in color. The Cu+3 and the Fe2+ ions appear green in color. The Fe+3 appears brown in color. The FeCl3 appears yellow in color, and the Mn2+ appear violet in color.
That's great. Can you discuss some questions based on the topic? It will be helpful for our viewers.
Usually the questions come under what is the significance of the formation of colored ions, or they will give you some metals and ask whether they are colorless or they are colored ions.
Okay.
That's all. Thank you, Teresa, for joining with me. You were so cooperative and supportive. Thank you, Teresa.
It was informative. Thank you for your time. I really appreciate the time and effort which you have put in the session. It was a fruitful one. Thank you, Josna, for your valuable words.
Thank you.
Teresa Joseph signing off. Thank you.
Let us now go to Jaren and witness a discussion between two college students, Komal and Kalyani.
So today, me and Komal are going to talk about the formation of complex compounds. So Komal, can you discuss what are complex compounds?
Okay, complex compound are the compound on dissociation it gives one complex ion, either cation or anion. So Kalyani, now let us discuss about the formation of complex compound.
Okay, mainly complex compounds are formed due to the small size of metal ions, their high ionic charges, and availability of d orbitals. So Komal, can you discuss some examples?
Okay, the first example is PTNX3 twice Cl2 and the second one is K4FeCN6.
Can you brief on that?
Okay, I will brief on PTNH3 twice Cl2. So in this compound, two NH3 molecules and two Cl ions use their lone pairs to bond with Pt2 plus ion. This compound is also known as cisplatin and they are used as an anti-cancer drug.
So is that solution colored?
No, it's a colorless solution. So, Kalyani, now let us discuss about the factors that affect the stability of complex compound.
For the stability of complex compounds, it mainly depends on the nature of metal ions and steric hindrance. Is it right, Komal?
Also, the resonant effect.
Okay.
Well, Komal, I have a question for you. Could you just tell us how does the size and charge of transition metals influence its ability to form complex compounds?
Okay, the size should be small and then high ionic charges. So also bond formation, easy bond formation. So let us conclude that transition metals forms a large number of complex compound.
Thank you, Kalyani and Komal.
Let's now see a different take on catalytic properties of transition metals by Irene and Ivana.
Good evening. Welcome to NDTV News. My name is Irene. Breaking news. Well-known cartoon character Augie's chocolate went missing from yesterday. We have Ivana reporting live from California. Hello, Ivana. Hello.
Yes, I can hear you, Irene. Yes, Irene, I can hear you.
Okay. So, what time did the incident happen?
The incident occurred around 12:30 p.m. at San Francisco.
Can you explain more about the incident?
I'm currently standing in front of cockroaches staying along with the wheat, which is a negative catalyst, increases the rate of reaction. What he came home and kept in bio catalyst and positive catalyst also increases the rate of reaction. So he came to solve this problem. He came to tell why found that process. He ran after the photo that and started later reaction. BOD needs to get to avoid create the that. So here both cockroaches with a negative catalyst decrease the fight by lowering the action.
Hello, Irene. It seems like you have been unmuted. Can you please?
Sorry. I'm sorry. Thank you, Ivana, for reporting the live news. Police concluded that DOD, which is the positive catalyst, have done this mainly due to two reasons. First one is variable oxidation state. Transition state elements keep on adding into NS and N minus and NS. When it keep on adding into a particular shell, then the oxidation state keeps on changing. Large surface area. Second reason is large surface area. Reactant absorbed on the metal surface and may form weak metal bond and provide space for other reactants to go and interact, or it provides free valencies through which the reacting molecules get absorbed on the surface. Examples for catalysts are: first one is vanadium pentoxide, then we have palladium, then nickel and ferric chloride. Thank you.
That was surely a different take on the catalytic properties of transition elements. Next, it is our privilege to be joined here by two experts, Evelyn and Nia, who will be joining the panel along with our very own Rahul. Welcome, guests. So let's start with Evelyn ma'am. So Evelyn ma'am, can you give us an idea how interstitial compounds are formed?
Okay, so interstitial compounds are those which are formed when small atoms like hydrogen, carbon, or nitrogen are trapped inside the crystal lattices of metals. They are non-stoichiometric and are neither ionic or covalent. Examples are titanium carbide, manganese nitride, iron hydride, vanadium hydride, and titanium hydride. These compounds are industrially important because of their special chemical characteristics. So now my very own friend Nia will say more about the chemical characteristics.
So now let's talk about the properties of the interstitial compound. The physical property, the melting point of these compounds are higher than that of the pure metal. This is because of the bonding between the metal and the non-metal, which are stronger than the metal-metal bonding. These compounds are very hard. The hardness of some borides are comparable to that of the diamonds. Now, chemical properties. These compounds retain metallic conductivity, which resemble to their parent matter in chemical property, but differ in the physical property, such as hardness and the melting point. And these compounds are chemically inert. Now, I hope you all got an idea on the properties and the formation of interstitial compounds.
Okay, so Nia, as you mentioned, there was a change in the hardness and the rigidity of these interstitial compounds. Uh, so what exactly is the reason that gives rise to such an increase in these two properties? So what is the main reason?
Yes, the reason behind it is because the vacant spaces are being filled by the atoms.
All right, Nia, thank you.
Thank you so much, experts, and thank you, Rahul. Now we'll be moving into a short break, and don't forget to keep watching our channel. Stay with us.
In the last decade, plastic has affected the health and life of human beings very badly. Use of plastic bottles and discarding them have led to its accumulation.
So, we are introducing stainless steel bottles, which are sustainable, durable, environmental friendly, and helps in save money.
Plastic bottles react with the drinks inside it in extreme conditions, whereas there are no harmful effects for stainless steel bottles due to absence of electrolytic activity.
Stainless steel is an alloy which is a homogeneous mixture of a primary base metal, iron, 11% chromium, and many other solids such as carbon, nickel, nitrogen, and aluminum. Chromium helps in providing it with resistance to heat, corrosion, staining, and it also prevents iron from rusting.
Stainless steel is an ideal material for bottle making. It enhances durability, sustainability, and is very strong.
It cannot be right to manufacture billions of objects that are used for a matter of minutes and then are with us for centuries.
Hence, we encourage you all to use stainless steel bottles and continue a lifestyle healthy for you as well as your environment.
Welcome back. Let me take you to our very own Augustus and Rahul as they interview a prominent scientist.
We regret to inform that we have just received word that prominent scientist Abu Bakr has met with an accident, and we as a studio hope for all to be well. So with that, this will be the end of this program, this special coverage. Hope you could understand and truly appreciate the vast world of the DNF blog and enjoyed watching this program as much as we did bringing it to you. So thank you so much. Keep watching. Stay with us.